I'm John Manier from Accu-Slice, and today I'm going to be evaluating this new sander from a company called Ultimation. It's a Canadian company that produces this small manual operated disc sander. And it's really designed for doing modeling, like model railroading and maybe dollhouse construction, very small wood construction. And it's manual rather than a motor, so there's no motor on this system. And the advantage of not having a motor is you get very slow speeds. Usually like when I'm cleaning up disc or something, I might use my big disc sander, but the big disc sander with a 12-inch disc is just too aggressive. I have a smaller 4-inch system on a motor, but again, that's pretty fast. And when you're going very fast like that, it tends to burn the wood, and it's a little hard to get more accurate cuts with the system. But this system is manually operated, and I thought it would be good for cleaning up segmented disc. So this is this new Ultimation manual disc sander. It has a 5-inch diameter disc, and right now in here I have a 120 grit sandpaper. The system consists of a 5-inch diameter disc with a table. The table is pretty thick. It's at least a 1/4 inch thick aluminum, and a square, perfectly square between the table and the disc. So when I'm sanding a piece of wood, I get nice straight perpendicular cuts. Also includes a fence here that you can adjust. So the one thing I did is I set my fence to 20 degrees. But that 20 degrees on this scale could be 20, it could be 20.5, it could be 20.2, it could be 19.5. It's just approximately 20 degrees. So I want to get this fence more accurate. When you're doing your segments for segment wood turning, they got to be accurate to within really a tenth of a degree. So I made myself some spacers or some adjustment pieces here, which are cut on the Accu-Wedge system. The Accu-Wedge system is pretty accurate. I cut a couple of these wedges on the system, and they all came out to exactly 20.0 degrees. But I wanted a couple of these that are a little bit off of that. I wanted maybe a 19.9, 19.8, and then maybe 20.1 or 2, just so I could have a little comparison between the different wedges. So I was able to put a piece of paper on the one side of my piece of wood when I cut it with the Accu-Wedge, and I was able to get a 19.8 and also a 20.2 wedge, just for comparison purposes. So I'm using these wedges to adjust my fence so that my angle between my disc and this fence is exactly 20.0 degrees. So that's what I use these for, just for adjustment purposes. Now the system has a nice handle on the right side, and there's a hub here with ball bearings inside, and this turns real smoothly, works really nice. And the disc doesn't wobble, it's nice and straight and square, so it turns out quite nice. So it should be able to do my wedges quite nicely. Now I just finished cutting a bunch of segmented disc, and I probably made about 80 segmented discs for some projects I'm working on. And all these discs came out perfect except these thick Purple Heart rings. And they were fine when I first cut them, but after they sat around for a couple of days, this Purple Heart must have had a lot of moisture in the wood, and it shrank. And as a result, I got a spacing here now. Well, it's probably maybe a tenth of a degree, but that's enough to give you a space that you don't get perfect joints in your system. So I was looking for a system to clean this up, and I know my power disc sander, my 12-inch disc sander, would just be too aggressive for this, and it wouldn't be very accurate for getting nice perpendicular sanded surfaces. So I thought this manual system might be a better way to clean these up. So that's what I'll be trying here, is using this to clean it up. The other thing I want to do is I have some segmented disc, and I glued some contrasting wood to the opposite side. And now I want to clean these up, clean that surface up to get a perfect square point. That when I join these together, I got perfect joints on my system going to a perfect point in the center. And I thought this might be good for cleaning these up also. So 2 things I'll be trying on this system today to see how it works. Now the first thing I found out, I have a sanding disc on here which is 120 grit, and I found that's really not coarse enough. I need something a little bit coarser to sand these segmented discs. So let me change this to a slightly coarser disc. Let me start with 100 grit sandpaper first, and maybe if we have to, I might have to go into a 60 or an 80 grit sandpaper. So this fence just opens up, then I can take these disc off, and these are pressure sensitive disc. small PSA disc. And the first thing I do is I clean this surface off with the glue. I'll use a little bit of denatured alcohol. I just have a rag here with some denatured alcohol just to clean off that surface to get rid of the glue from the previous disc. There's a little bit of a gap on it, you should be able to see that. It's not quite perfect in the center. So let me try cleaning up these discs and see how it works. Now, originally I was planning on putting a motor on here. Some would operate maybe 20 to 50 RPM. But I found out that didn't work because what happened with the motor on here, when I was sanding it, it actually caught in there and I wasn't able to get it out. When I'm doing it manually I can turn it, and then to get it out I just reverse my disc. This seems pretty good. So let me just go through each of these and we'll sand them and see how it goes. So I push my piece, it's flat against the table, keep it nice and keep my sides perpendicular, and just keep it in between my sanding disc and this fence, and just lightly sand the surface. Reverse the wheel to get it out. And let's go through all our discs like that and sand them all. Try to do about the same amount of sanding on each one. I'm actually sanding both sides. Because the problem may not just be the disc, it may be a little bit of a burr left on from the cutting of the pieces. So just enough to clean it up. For viewing purposes, I've sped up the actual sanding about 5 times the actual sanding speed. And I am sanding both sides of each of the wedges and trying to do the same amount of sanding on both sides of all the pieces, just to try to keep all the pieces the same uniform thickness. And here we're sanding the last segment at wedge. Well, a little bit of sanding made a big difference. That's near perfect. So I have a couple more small ones to do here. Then I have this big one. This is where the biggest gap is in these bigger, thicker discs. You can see this here, but that's a significant gap there which I got to eliminate. I moved all the discs together, and that's the total gap there. It's maybe a 32nd of an inch on the outside there. So this might take a little more sanding to get these chewed up. I'm sanding both sides of each of the segmented wedges and rotating the disc about 20 revolutions for each side in an attempt to keep all the wedges the exact same thickness. And then I sand the final segmented wedge and then reassemble the disc and put a rubber band around it to check the accuracy. Well, a little bit of sanding made quite a difference. They're much better. And what I did there is I did like 20 rotations for each side of the wedge. But they came out real good. Now, as I mentioned earlier, I made these discs, these segmented discs, or segmented wedges I should say, and I, in this case, it was a purple heart, and I glued a 20,000th inch strip of yellow heart to the one side, and I sanded off the edges. And now I want to sand this surface to get a perfect flat surface here, so that these all come to, to a perfect point when I glue these together. So let's see how this works. So there's my before, and here's my after cleaning it up. Now there's a total of 4 of those done and put together. I really can't say too much till I do a complete ring of 18 of these, see how they come out. But they look pretty good. The system works pretty good for cleaning them up. I think a 20,000 inch thick spacer is too little. So I did make some here with about a 50,000 inch thick spacer. Let me try cleaning these up. Well, first of all, I got my edges to clean up. Let me do those first. Now the one thing I can do, if I run this this way, it kicks the piece up. So I can always run it backwards, to clean it up, to do this other side, because I don't want to have to keep resetting my fence. So I can just do this to clean up the edges. Well, I cleaned up these edges here, and there, and also there. Now let me finish to do this wedge up. Yeah. Now that's the finished piece. Probably see it much better from looking like that. Came out pretty good. Here's before and after. So again, that's a future project. That'll be in a future video on some of the bottom segments I'm working for this video series I'm working on right now. A couple more of those I can do. Again, first of all, cleaning it up. Being able to do this in reverse actually works out quite nice here. Otherwise, I'd take my fence off. But just by running in reverse, I can leave the fence where it is. This 100 grit seems pretty good. I think the 120 was a little too fine. Well, there's 3 of those discs, and those look pretty good. Those came out nice. So this new system worked nice for making these discs. So that'll be in a future video. I'm working on a video on making base plates for segmented rings, and this will be a base plate in the near future. Now one thing more, I mentioned earlier that I did put a motor on here to try to test it out. So let me, even though that didn't work out too well, let me show you how I hooked that up. Okay, this is the system I put together. It consists of a 24 volt power supply, a rheostat with a switch that I can adjust the speed of the motor. There's a simple 24 volt motor I bought on Amazon, and I had to make an adapter to adapt the motor to the shaft here. So to hook this up, I just have to remove the handle. I just have a spacer here to mount the motor on it so it doesn't twist. If this was permanent, I actually mount this, but it was just a test. And now with this reset, I can adjust the speed, from slow speed up to 200 RPM. And this worked fine for sanding the pieces. So it's hard to get the pieces out. They're getting jammed in against there. If you do it manually, you can reverse the motor, but when I'm doing it automatically, I can't reverse the motor. But if I'm very careful, it does work. Let me try one of these. This is one that has a decent sized gap. So let me see if this will work on this. Definitely be easier and faster because it gets a little bit tiring, turning it, 20 turns times, 18 pieces. But let me give it a try here and see how it works. Yeah, that actually might work. It didn't work very well on these pieces going to a perfect point. But in this larger point where it doesn't, larger piece where it doesn't go to a perfect point in the center, I can actually hold it like this, and I can pull it back and forth. So that actually does work. Motor's a little weak, could be a little bit stronger motor. So let me go ahead and do this whole set of 18 and see how it works. Well, I cleaned it up really good. Gaps are all gone. So this motorized system worked very well for doing these segments that didn't go to a perfect point in the center. When they go to a perfect point in the center, the problem is it gets jammed in there, and it's hard to get out without reversing the motor. See, even just doing it manually, it's hard getting out. But what I do need here is a little bit larger motor. This motor is a little bit underpowered, so I need something at least 2 or 3 times the power. And probably that's a good speed, around 200, maybe 300 RPM would be a good speed for this. But definitely under 500 RPM. Unlike a regular disc sander, which goes at 1800 RPM, this is much better going slower. The other thing I could use on here is probably a dust shield. Start collecting some of this sawdust. I'm starting to get quite a bit of sawdust build up in here. And that 100 grit disc worked pretty well. Well, this concludes this video on this Ultimation Disc Sander. I'm quite pleased with the operation. I said I bought this to do some cleanup of segmented disc, and it did do a good job doing that. A couple of things I think would be needed. It'd be nicer if the disc was, 6 or even 9 inches in diameter. I know there's another manufacturer of a system, again in Canada, who makes a manual system that's around $1,000, but it's a 9-inch disc with replaceable disc. I considered buying that, but it was $1,000 and this was only like $250, so it's just better trying this out to see how it worked fine. But it did work fine for doing the small disc going to a perfect point in the center, and doing these multi-layer where I added a strip to a segmented disc. Using the manual system worked quite well. But doing these larger blocks, the automated system with a motor on here, definitely much easier. It gets to be tiring, cranking this handle a lot of times for doing a lot of segmented disc. Especially when I'm doing, maybe half a dozen discs and 18 segments per disc. It's a lot of turning, so definitely the motorized system is better. But I said a couple of changes I would recommend going forward. A larger disc definitely would be better for the system. At least 6, if not 9 inches in diameter. I need a stronger motor if I'm going to automate this for doing manual or doing automated turning. Probably at least 2 or 3 times power on the motor. And probably between 200 and 500 RPM would be a good range of speeds for the system. But the system worked quite well. This was perfectly perpendicular between the disc sander and the plate, and this fence worked nice. I originally thought I might need a taller fence, but I don't think so. This seemed to work fine, just enough to catch the edge and keep everything flat against the disc. A taller fence might make sense, so I might consider that too in the future. But you'll see this and definitely in future videos as I'm making some of these segmented discs for these 2 video series I'm working on. I'm working on a video series on making a segmented bottom disc for bowls, and then another video system on making feature rings for bowls. So you'll see those 2 video series coming up in the near future. And I'll be using this system to clean up the disc that I need cleaned up, especially when I'm making adding strips to a segmented wedge, or if I have to clean up disc, to get them perfect. I said these systems work perfect when I cut them. It's just as they dried out, apparently with some moisture in the wood, and as I cut the small pieces, that moisture got released and the wood changed shape a little bit. But as I said, I made like 80 other discs and they all came out perfect. I mean, these weren't cleaned up at all. These are right off the system, and there's no cleanup on those. This system was really designed for doing model railroading projects and other small woodworking projects. And I bought this system with the idea of using it to clean up segmented disc. And it did work quite well, and I definitely would recommend this for other people who want to use a system for cleaning up your segmented disc. I'm not affiliated with this company. It's a total separate company. I had to buy this system. It was not donated to me, so it was a purchase on my part, just for testing purposes. But I do recommend the system. I'll be using it quite a bit in the future, and you'll see it in my future videos. So once again, thank you for watching this video. If you have any questions or concerns or comments, as always, please give us a call or drop us an email. And thank you for watching.